Okay, so hopefully you've picked up one of these before you are watching the video. If not, you'll just have a little bit more work to do as far as writing down some columns in your notebook. We're going to talk about these algebra proofs. Even though they are algebra proofs, they are algebra reasons, they work the same with geometry, segments, and angles, etc., which we will be building into. So the first thing you need to understand is all the individual proofs. I'm going to zoom this in a little bit. The addition property of equality states if A equals B, then A plus C equals B plus C. So what we are doing is we are adding the same number to both sides of an equation. When I think of this, and you can adjust this or add some things onto it as you want. When I think of the addition property of equality, I think of if I have something like 2x minus 4 equals 6, and I am wanting to solve that equation, I am saying that right now 2x minus 4 does equal 6, and I can begin to solve this equation by getting the 2x all by itself. So I can add 4 to both sides of the equation. By me adding 4 to both sides of the equation, this is using the addition, and you can abbreviate, property of equality. So that's what I think of. Let's move on to the subtraction property of equality, which is the next one. Same idea. If A equals B, then A minus C equals B minus C. Again, what we are doing is we are subtracting the same number or the same value on both sides of the equation. So if I were to think of an equation, it would be something like 3x plus 1 equals 7. I would begin to solve that by subtracting 1 on both sides of the equation. Again, by subtracting 1 or doing the same thing on both sides of the equation, I am using the subtraction property of equality. Because you need to think about what an actual equation means. It means that the left side of the equal sign has to equal or stay in balance with everything that is on the right side. They may look the same, they may look different. Multiplication property of equality is the next one. If A equals B, then A times C equals B times C. So we are multiplying both sides of the equation by the same number. Again, another algebra example I can think of would be, let's do x over 4 equals 8. Okay, so right now we are dividing, so we know to do the inverse. So if we are dividing by 4, we're going to multiply both sides by 4. So I'm multiplying both sides of the equation by the same thing. Those are going to cancel out, giving you x equals 32. But by multiplying both sides by the same number, you are using the multiplication property of equality. Moving on to division. Division has a little bit of a restriction, and it states if A equals B and C does not equal 0, then A divided by C should equal B divided by C. Now it's important to understand why there is this restriction, and that is because C is in the denominator of both of these fractions, and 0 cannot be in the denominator. So 0 cannot be in the denominator of any fraction. Okay? 0 cannot be in the denominator of any fraction. So if I put this in algebra terms, let's do 2x equals 14. So if I were to solve this equation, I want x by itself, Right now I'm multiplying, so I need to divide both sides of the equation by 2. So again, dividing, this is going to be the division property of equality. The distributive property, you guys have seen this for quite a while. It's a quick way of multiplying, quick way of adding. So instead of me, I'm going to use an algebra example. Instead of me doing 5 of these, meaning that I have to do 2 plus 1, plus 2 plus 1, plus 2 plus 1, plus 2 plus 1, plus another 2 plus 1. I'm keeping this with algebra in mind. I could do 5 times 2, or I have 5 2's, which gives me 10, and then I have 5 1's, or 5 times 1 gives me 5. So I would get 15 when everything was all said and done. Keep in mind, this is not always going to be just a numbers question. You're going to have some variables chucked in there. So I'm going to do one with some variables in there. So if I have 3x plus 2's, I don't need to do 3 of these, x plus 2, plus x plus 2, plus x plus 2, and then go through and combine like terms. I'm going to go ahead and do that so you can see what I'm talking about. I don't need to do that and then combine. I have an x and an x and an x and get 3x. And then a 2 plus a 2 plus a 2 gives me a plus 6. That's a long way of doing it. Using the distributive property, I could do 3 times x, which gives me 3x, and 3 times a positive 2, which gives me a positive 6. Much quicker than having to expand it. Simplifying like terms, what I want you to understand with this is that this is on the same side of the equal sign. Same side of equal sign. Okay, that's really important. So this would be if I had, let's see, I don't know if I really like how they have it written here. Here's an example I'm thinking of. If you have 2x plus 3x equals 10, I am not doing anything to both sides of the equal sign, so that's why it's not a property of equality. I am just combining like terms. I have 2x's plus 3x's gives me 5x's and equals 10, and then we're right back to another property of dividing by 5. So this is when you are combining terms on the same side of the equal sign. You need to remember that you have like terms. So if you have 2w plus 5w minus 4, think of nouns. 2 whales plus 5 whales gives me 7 whales. And I cannot do anything with the 4 because it's not a like term. The symmetric property of equality states if A equals B, then B equals A. And when I think about this one, I like to think of it as when you solve an equation, there's no difference that if you have x equals 6, I'll make that look more like a 6. That's a terrible 6. That is the same thing as 6 equals x. A lot of times when you're doing algebra proofs, you are going to want your answer like this, but you end up like this, so you're going to have one more step of taking everything on the left of the equation and putting it on the right, and vice versa. So if I think of some examples here, it would be something like I just did, if you end up with 2 equals x, you need to know that you can then write x equals 2 using the symmetric property. If you have 2 plus 3 equals 5, what you'd be doing is taking the stuff on the left and putting it on the right, and vice versa. So then 5 would equal 2 plus 3. So those are some examples of some of the properties. Reflexive property, it's honestly not used too much with algebra, but definitely with geometry when we start proving triangles congruent. So reflexive would mean that the right side equals the left side. So if, let's just do A equals A. Okay, the left side has to be exactly like the right side. 2 plus 3 equals 2 plus 3. Must be identical. Here's an example of not the reflexive property. 2 plus 3 equals 5 is not the reflexive property. 2 plus 3 equals 3 plus 2 is also not the reflexive property because it is not identical. Okay? The transitive property, when I think of transitive, I think of a train. Okay? And every train has an engine and a caboose. But everything in between, the number of cars, that's when it starts to vary. So if A equals B and B equals C and C equals D and D equals E, then, so if I look at this, I have an engine. This is where I started. All of these are linked together. And this is where I end. That's my caboose. Then A equals E. That's an E. If I think of an algebra problem, if 2 plus 1 equals 3 and 3 equals 4 minus 1, then 2 plus 3 equals 4 minus 1. And substitution, I kind of think of this as a catch-all. Substitution is if you're taking a value and substituting it in for another value. There's a couple of examples. If you take 4 squared and in the next step you write it as 16, to me that is substitution. If you have x plus 3 equals 5, and you know that x equals 2, so in the next step you get 2 plus 3 equals 5, that is substitution, because we have taken the 2 and put it in for that x value. When we talk about, we'll be building more on this when we get into geometry as well. Substitution is taking a value, so if A equals B, and B equals, I'm going to scratch that one. We're going to stop there on the substitution property. Okay?